Hello everyone, and welcome to this video all about Git and the common commands and workflows you're likely to see. Let's start with the most common Git workflow you'll use on almost every project. This requires that you are in a local repository on your computer that is connected to a remote repository on a host server. We'll start by summarizing the typical workflow briefly, but we'll expand on it more later. Step 1 is to pull from the remote repository to make sure your local copy is up to date. You can do this with the git pull command. Step 2. If you're working on something new, you might create a branch so your changes stay isolated. The -c flag will create a new branch. Without it, you will be switching to an existing branch. Step 3 is to make any changes to your code or files. Step 4, you stage the changes with git add. Using git add dot adds all changes in the current working directory. Step 5, you commit those changes with a descriptive message. Step 6, if you used a branch, you can later merge it back into main. Do this using the git switch command and the git merge command to pull your changes from your source branch. Step 7, finally, you push your work up to the remote repository so your teammates can see it. That's the Git cycle you'll repeat over and over again. Pull, branch, change, add, commit, merge, and push. Let's take a look at what that looks like more conceptually. You can think of it like this. Imagine we have some sort of remote server. This would be something like GitHub. And on that remote server, we have a repository. The repository contains a snapshot of code as of that point in time. But on our local computer, we have nothing. The first thing that we're going to want to do is clone this repository so that we have our own local copy. This will be done using the git clone command. Once we have a local copy, next it's time for us to make changes. To make changes, you can pull open your favorite IDE and just begin editing your code like you normally would. Once you're happy with your changes, it's time to let Git know that we have something that we're prepared to save as a snapshot. You can take these files and changes that you've made and put them onto the stage using the git add command. Once all the files that you want to modify in this snapshot are on the stage, you're now ready to make your first commit. To do this, we will use the git commit command with the -m flag, as well as a short and concise message about what is going to happen in that commit, such as adding some sort of feature. Once this is complete, we've now added to the history of our Git repository. We have a new commit that's storing a snapshot or a save point of our code. The issue now is that the server doesn't know about this. So what we need to do is get those changes pushed to the server. To do so, we will use the git push command. This will allow the server to track all of our local changes. This makes it so another user that wants to see the current changes on the server will have a correct and up-to-date copy of your own code. Now, let's say somebody else decides to make their own commit and push that onto the server. Well, see, now you are behind. So in order to be tracking all changes on the remote server, we need to use the pull command. The pull command will get us up to date with the remote repository so that everything is in sync. And so this becomes your basic routine. Pull, change, add to the stage, commit, so it's on your local timeline, and push so that it gets added to the remote repository. Now let's take a step back. What is version control? Version control is a system that tracks changes to files over time. It lets you roll back to earlier versions, compare edits, and collaborate with others without overwriting each other's work. In the past, many teams used centralized version control systems like Subversion. With these, there's one central server that stores the code. Developers check out files, make changes, and then check them back in. This workflow has a couple flaws. If the server goes down, no one can work. And if you check out one or more files to work on, those files would often become locked, preventing others from working on them until you've finished. Git is different. Git is a distributed version control system. That means every developer has the full history of the project on their own computer. This makes Git faster, more reliable, and better for collaboration in modern workflows. So how does Git actually work? At its core, Git is about repositories, or repos for short. A repository is your project's history, all the files, and all the changes that have ever been made. Inside a repo, every time you save your work with Git, you make a commit. A commit is like a snapshot in time. You can also think of them like a save point in a video game. In the future, if you don't like where things are going, you can always return to a previous save point. Commits can be grouped into branches. Think of a branch as a timeline. You can have alternate timelines that are all running simultaneously. The main branch, often called main or master, is where stable code lives. But you can create new branches to experiment, fix bugs, or build features without messing up the main line of development. Before we can start using Git, let's make sure it's installed. From inside your repository, you should run git -- version. If you see a version number, you're good to go. If not, you'll need to install Git from their website or your system's installer. Next, let's set up some basic configurations so Git knows who you are. This is important because your commits are labeled with your name and email. Use the git config command with the global flag. The global flag means this applies to all repositories on your computer, so you'll only need to do this once. We'll set the user.name argument with your name in a string and the user.email with your email in a string. Now we're ready to start using Git. To initialize a brand new repository in the current folder, use git init. Or if you're joining an existing project, you usually clone it from a remote server like GitHub. For this demo, we'll clone a remote repository. To do this, use the git clone command followed by the URL of the remote repository. Once you're inside a repo, you can check what's going on in Git anytime with git status. This shows you how your local repo compares with the remote server, which files have changed, which are staged, and what's ready to commit. You can also view your recent commit history with git log -- one line to keep it concise. This brings us back to our typical workflow. Use git pull to ensure you're up to date with any changes on the remote server. Optionally, you may create a branch to isolate your changes. We'll talk more about branches in a bit. Next, you'll make any changes that you'd like to your code and files. Then, to save your work, stage the files using the git add command. Now often, you don't want everything tracked by Git. For example, log files, build outputs, or sensitive configuration. That's where a special file called the gitignore comes in. Inside gitignore, you list patterns for files Git should ignore. For example, star.log uses the wildcard pattern to ignore all files that end in the .log extension. Node modules followed by a / will ignore all files that are under the node modules directory or folder. .env would just ignore a single file. And this works for other similar files as well. You can quickly build a gitignore tailored to your project at gitignore.io. It's a website that allows you to add the language and toolset that you're working with, and it will generate a file with commonly ignored extensions and directories for your project. This keeps your repo clean and prevents sensitive or temporary files from accidentally being pushed. Next, we want to commit to save a snapshot. Use the git commit command with the -m and message that you'd like to save in the commit. This snapshot then gets added to our timeline. You should think of this message as a subject in an email. It should be concise and readable within 2 to 3 seconds. You may optionally add another -m message, which follows the first -m message, if you'd like to add a more verbose description. Now your snapshot is stored in Git's history. To see the history, you can once again run git log -- one line. If you branched before and are done making changes in this isolated branch, now is the time to merge. Use the git switch main command to switch to your destination branch for your merge operation. Then use git merge with the branch name of the source branch from which you want to pull these changes. But all these changes only exist in your local repository. To update what everybody else sees on the server, you need to finally run git push. And this is what a typical cycle of your regular Git workflow might look like. Next, let's talk more about branching and merging. Branching is one of Git's most powerful features. To create and switch to a new branch, as we've seen before, you can use the git switch with the optional -c flag and a branch name. If the branch already exists, you can just run git switch and the branch name. Abstractly, branches act as a new timeline for our code. After making commits on that branch, you can merge them back into main as we saw before in the typical workflow. Use git switch to go back to main, and then git merge with the source branch name that you're trying to pull in. This will create a new merge commit. This merge commit will contain all of our changes from the source branch, bringing them into the destination branch. We can switch back to our timeline and think of it a little bit like this. If we are currently on our local computer and we want to continue making changes but on a new timeline, we can use the git branch -c feature. Then we can start to make commits like normal. We'll make some changes, and then we'll make another commit. Changes, and commit. When we're finally happy with everything that we have, and we're ready to push this back to main, all we need to do is use git switch to come back to the main timeline. And then what we're going to do is call the git merge command on our branch. I'll call this B1. So when we say merge B1, what we do is create another commit here in main that's going to contain all of the changes from our other timeline or branch. To see all available branches, you can just use the git branch command without any arguments. This will show branches available to switch to, as well as the branch that you currently have checked out. Sometimes you want to look at an older version of your project. To explore a past commit without changing history, you'll first want to see your commit history so you can select a correct commit. For this, we'll once again use the git log -- one line and the optional -10 flag. This will allow us to view the past 10 commits in a concise manner. To select the commit that you want to view the snapshot of, use git switch with the detach flag and the hash of the commit that you'd like to view. To safely undo a commit, use the git revert command with the commit hash that contains the snapshot you'd like to revert to. This will create a new commit as a snapshot that matches the commit hash you provide. And if you really need to move your branch back to an earlier commit, you can use git reset -- hard with the commit hash that contains the last commit you'd like to keep in history. Be careful though, the reset command rewrites history. So what if you make a mistake? Git makes it easy to undo. Let's talk about changing history in Git. To discard changes in a file before they are staged, you can use git restore and the name of the file, or a list of file names that you'd like to reset to their status as of your last commit. To unstage a file but keep your changes, use git restore with the -- staged flag and the list of file names that you'd like to remove from the stage so you can make further changes, or remove those files from being part of your next commit. Let's talk a little bit about what these look like conceptually. So, Git restore is in charge of taking any file changes that you've made, say, here. Any file changes that you currently have will be completely removed, and you'll be looking at the status of your most recent commit. Let's say this was our most recent commit, and you were making changes on your new branch, but you decided you didn't like these changes, so you say git restore and the name of those files, and it's going to get rid of them. Now, git revert is a more safe way of undoing these changes. Let's say that we're on this commit up here. If we want to restore to a previous state of the code, say this commit back here, we can use git log one line to get the commit hash, and then what we can do is say, hey, I want to revert the status back to that commit. So if we run this revert command, it's essentially the same as going back in time. Now this commit that we've just created matches the previous commit that we had. All changes that existed in this time frame are still kept in history in case we want to look at them. However, those changes are not applied on this new reverted commit. Once you're comfortable with the basics, Git gives you tools to clean up and manage history. To mark important points in history, like releases, you can tag a commit using the git tag command followed by the name that you'd like to tag it with. If you want to share that tag with others, you need to make sure that you push it to origin, which is the remote server. To combine multiple commits to one, you can squash them during a rebase. Use the command git rebase with the -i flag for interactive, and using head -3 would be allowing you to select the previous 3 commits. Here, you'll change pick to squash in the interactive terminal, and this keeps the changes from multiple commits, but rewrites history as if they were a single commit. Great for tidying up before sharing your work. Conceptually, you can think of this as the following. Imagine we made this branch as before, but this time, instead of having 3 commits in history, each with their own changes, let's say that we wanted all 3 of these commits to count as 1. In this case, we use the git rebase -i head -3, and you'll see that we have something like pick, pick, and pick. And what we can do is just change these picks to squash. And the Git system will turn all of these into a single commit with one message and all of your changes intact. To remove the latest commit completely, you can use the git reset command as we've seen before. Using the --hard flag and argument head tilde and however many commits you'd like to delete will completely remove these commits and their changes from history. Be careful, it's destructive, and there is no way to recover commits which are deleted. So you can think of it like this. This is our current head of our main, and if we use the command reset with the argument hard and head -1, that is essentially saying we want to reset the changes that occurred here, we want to force these changes to occur, and we want to go back from head 1 commit. That means this commit will be completely deleted. There is no way to recover it. Alternatively, git reset with the --soft flag will remove the commit, but keeps your changes locally, so you can recommit them in a cleaner way. Conceptually, we can think of it like this. If we use reset on our current head with the soft flag, and again, we just want to step back one commit, so we do head -1, it's going to remove this commit. However, any changes that occurred in the meantime are going to come back to our local file system and be saved as changes here. And maybe saved isn't the right word, but the changes will be available so that we can once again stage them and then continue adding them to our commit timeline as we see fit. To rename your last commit, use the command git commit with the --amend flag. Same as the normal commit protocol, you will use -m followed by a message for which you'd like to replace the previous commit. You can think of it like this. If this commit at our current head had some message that said, hey, here's a feature, and it adds something useful to our code base, if we use the --amend feature with a new message, we can essentially change whatever this says to maybe something else. This will occur without making any changes to the actual file content of that commit. It will only adjust the message. And to rename an older commit, you can rebase and mark the commit with the message you'd like to modify as reword. Once again, we'll use the git rebase command for that with the -i flag to use the interactive terminal. This will allow us to mark one of the picked commits with reword and allow us to change the message that is bound to it without changing the file changes that occurred in that snapshot. These commands are all powerful, but use them carefully, especially if you're working on a shared repository. In this tutorial, we started with the everyday Git workflow. We explained version control and why Git is different from older centralized systems. We covered local basics, branching, merging, undoing changes, working with remotes, and even some intermediate tools like tagging and rebasing. Your next step is practice. Create a small project, initialize a repo, and walk through the workflow yourself. The more you use Git, the more natural it becomes. From here, you can explore GitHub or GitLab collaboration, pull requests, and more advanced workflows. Thanks for watching, and happy coding!